Welcome to my channel, The Proper Guidance. Here we are today to discuss about computer networks, chapter number 10, class 12, computer science. Okay, so let's start computer networks. In this chapter, we will learn about evolution of networking, types of networks, network devices, networking topologies, identifying nodes in a network communication, internet, web, and the internet of things. Domain name system. So these are all the topics we will be discussed here. So first part, introduction to computer networks. So here is a diagram that is interconnection forming a social network. In our daily life, you are very much used to with internet, and when we use internet, this is nothing but a huge connection and elaborate connection, right? So the very basic thing is about networks. After that we will go to internet section. So what do you mean by computer networks, right? We are living in a connected world. Information is being produced, exchanged and traced across the globe in real time. It's possible as almost everyone and everything in the digital world is interconnected through one way or the other. Okay, so a group of two or more similar things or people interconnected with each other is called a network. This is the very basic definition of a network. That is a group of two or more similar things or people interconnected with each other is called a network. Some of the examples of network in our everyday life includes social network, mobile network, network of computers, airlines, railways, banks, hospitals networks, each and everything. We are familiar with this networking system in our today's life, right? A computer network is an interconnection among two or more computers or computing devices, and in this chapter we will learn about this thing. Such interconnection allows computers to share data and resources among each other. A basic network may connect a few computers placed in a room. The network size may vary from small to large depending on the number of computers it connects. That is a computer lab. You are used to with a computer lab. There are so many computers in a computer lab and they are interconnected with each other. You can share information or anything. Okay, a computer network can include different types of host, also called nodes. Like there may be a server computer, desktop, maybe laptop, or maybe cellular phones. Okay, so this is the very basic concept of a network and about especially computer network. Clear? Apart from computers, networks including networking devices like switch, router, modem, etc. These terms are also very familiar nowadays. That modem, what is the usage of modem? Router is, you can see a router in a computer lab. Okay, so networking devices are used to connect multiple computers in different settings. For communication, data in a network is divided into smaller chunks called packets. These packets are then carried over a network. Devices in a network can be connected either through wired media like cables or wireless media like air. Okay, so there are two types of connection. That is, one is wired connection and another is wireless media like here. In a communication network, each device that is part of a network and that can receive, create, store or send data to different network routes is called a node. This is the definition of node. In the context of data communication, a node can be a device such as a modem, hub, bridge, switch, router, digital telephone handset, a printer, a computer or a server. Clear? Now, interconnectivity of computing devices in a network allows us to exchange information simultaneously with many parties through email, websites, audio or video calls, etc. Network allows sharing of resources. For example, a printer can be made available to multiple of computers through a network. A networked storage can be accessed by multiple computers. People often connect their devices through hotspot, thus forming a small personal network. Okay. Now we will learn about evolution of networking. So this is history of networking. So today this is the evolution of networking part. In this section we will learn that how the networking system has had been evolved. Okay. So in the 1960s, a research project was commissioned by Advanced Research Project Agency Network, that is ARPANET, in the US. Department of Defense connect the academic and research institutions located at different places for scientific collaborations. The first message was communicated between the University of California, Los Angeles and Stanford Research Institute. Slowly but gradually, more and more organizations joined the ARPANET and many independent smaller networks were formed. Few of the milestones in the magnificent journey of evolution of computer networks is depicted in the timeline shown in the following figure. You people please go through. This is 1961, ARPANET is here. 1969, ARPANET become functional by connecting UCL and SRI. 1971, Roy Tomlinson develops network messaging or email system, and today's we are much more familiar with email system, right? In 1974, the term internet was coined. First commercial use of ARPANET was started in the name of Telenet, and then 1982, TCP or IP introduced as standard protocol on ARPANET. In 1983, domain name system introduced. In 1986, National Science Foundation brings connectivity to more people with its NSF-NET program. And then in 1990, the Berners-Lee at CERN developed HTML and URL, thus giving birth to World Wide Web, that is WWW. And in 1997, first version of Wi-Fi standard was introduced. And in today's world, this is 2023, there are much more advanced feature of networking system. And this is just a history of evolution of networking. You people please go through. And then the most important topic in this chapter, that is types of networks. How many types of networks will be there? We will just learn it. There are various types of computer networks ranging from network of handheld devices to connected Wi-Fi or Bluetooth within a single room to the billions of computers spread across the globe. Okay, some are connected wireless while others are connected through wires. Based on the geographical area covered and data transfer rate, computer networks are briefly categorized in these following sections. That is, first one, PAN, means personal area network. Then LAN, local area network. Then MAN, metropolitan area network. Then WAN, means wide area network. Now one by one we will discuss the points. First one, personal area network, PAN. The name implies that it is a network formed by connecting a few personal devices like computers, laptops, mobile phones, smartphones, printers, etc. as shown in figure 10.4. Here is a picture you can see, and that here is a printer, computer, two laptops are here, smartphone, mobile phone, audio device, all these things are there. All these devices lie within an approximate range of 10 meters. Our personal area network may be wired or wireless. For example, a mobile phone connected to the laptop through USB forms a wired PAN, while two smartphones communicating with each other through a Bluetooth technology from a wireless PAN or WPAN. Okay, so this is our first point. After that we will learn local area network. It is a network that connects computers, mobile phones, tablet, mouse, printer, etc. placed at a limited distance. The geographical area covered by a LAN can range from a single room, a floor, an office having one or more buildings in the same premises, laboratory, a school, college or university campus. The connectivity is done by means of wires, Ethernet cables, fiber optics or Wi-Fi. a local area network is shown in the following figure. You can see it now. Here is maybe Wi-Fi connection or Ethernet cable will be there. Mainly in your computer lab, you can see LAN here, okay? Or in a school or university, college building, in office building, LAN is used very often. LAN is comparatively secure as only authentic users in the network can access other computers or shared resources. Users can print documents using a connected printer, upload or download documents and software to and from the local server. Such LANs provide the short-range communication with the high-speed data transfer rates. These types of networks can be extended up to 1 kilometer. Data transfer in LAN is quite high and usually varies from 10 Mbps called Ethernet to 1000 Mbps called Gigabit Ethernet, where Mbps stands for megabits per second. Ethernet is a set of rules that decides how computers and other devices connect with each other through cables in a local area network. So this is all about LAN. After that, the next network, Metropolitan Area Network, MAN. Metropolitan Area Network is an extended form of LAN which covers a larger geographical area like a city or a town. Data transfer rate in MAN also ranges as Mbps, but it is considerably less as compared to LAN. Cable TV network or cable-based broadband internet connection, internet services are examples of MAN. This kind of network can be extended up to 30 to 40 km. Sometimes many LANs are connected together to form a MAN, shown in the following figure. See here, there is LAN 1, LAN 2 and LAN 3 networking devices here, and it forms a MAN, that is Metropolitan Area Network. The next and last one, that is Wide Area Network, that is WAN. Wide Area Network connects computers and other LANs and MANs which are spread across different geographical locations of a country or in different countries or continents. A WAN could be formed by connecting a LAN to other LANs via wired or wireless media. Large business, educational and government organizations connect the different branches in different locations across the world through WAN. The internet is the largest WAN and that connects billions of computers, smartphones and millions of LANs from different continents. So here is the diagram of wide area network. So you can see here that there is a network switch, that is LAN 1 in Delhi, LAN 1 in Shimla also, and internet. Maybe whatever may be the name, different geographical location it can follow, and the internet today is under this category, that is wide area network. Okay, so these are the common types of computer network, and after that we will learn about network devices. This is also very important point, that what are the devices used for computer network. To communicate data through different transmission media and to configure networks with different functionality, we require different devices like modem, hub, switch, repeater, router, gateway, etc. Let us explore them in detail. First one is modem. We all know the name modem. This term is much more familiar, and modem stands for modulator, demodulator. Okay, it refers to a device used for conversion between analog signals and digital bits. We know computers store and process data in terms of zeros and ones. This is the most important line that we all know, no? That the computers we use, they are all binary computers, and computers store and process data in terms of zeros and ones only. However, to transmit data from a sender to a receiver or while browsing the internet, digital data are converted to an analog signal, and the medium, be it free space or a physical media, carries the signal to the receiver. There are modems connected to both the source and destination nodes. Okay, the modem at the sender's end acts as a modulator that converts the modem at the sender's end acts as a modulator that converts the digital data into analog signals. The modem at the receiver's end acts as a demodulator that converts the analog signal into digital data for the destination node to understand. This is the very functionality of a modem. So here is that particular picture use of modem. Look at the picture. First one, digital signal is sent through a laptop. Here, modulation, demodulation. The red ink is a red arrow for modulation. And when digital signal, you can see it, digital signal in 0 and 1, 0 and 1. This is the diagram of digital signal and graphical representation, you may say it. And after that, when it is passing through modulator, that is the modem, from the sender's end, it will be converted to an analog signal. You can see it in the blue ink. This is analog signal. And after that, telephone line is here, another modem is there, and when it passes through this modem, again a modulation happens, and when the modulation is completed, then again this particular analog signal is converted to the digital signal, and the receiver will get that particular digital signal, and vice versa. From when this machine is acting as a sender, then the same thing happened here for the receiving machine also. Okay, so this is the use of modem. After that, Ethernet card. Ethernet card, a network interface card, you can see in the picture 10.9. Ethernet card, what is it? Ethernet card, also known as network interface card, NIC card in short, is a network adapter used to set up a wired network. It acts as an interface between computer and network. Okay, it is a circuit board. It is a circuit board mounted on the motherboard of a computer, as shown in figure 10.9. You can see it in your motherboard of your computer. The Ethernet cable connects the computer to the network through NIC. Ethernet cards can support data transfer between 10 Mbps and 1 Gbps. Okay, that is 1000 Mbps. Each NIC has a MAC address which helps uniquely identifying the computer on the network. Okay, and then RJ45. What is RJ45? RJ45 register Jack 45 is an 8-pin connector. This is an 8-pin connector that is used exclusively with Ethernet cables for networking. It is a standard networking interface that can be seen at the end of all network cables. Basically, it is a small plastic plug that fits into RJ45 jacks of the Ethernet cards present in various computing devices. Clear? After that, we will learn about repeater. What is repeater? Data are carried in the form of signals over the cable. These signals can travel a specified distance, usually about 100 meters. Signals lose their strength beyond this limit and become weak. In such conditions, original signals need to be regenerated. A repeater is an analog device that works with signal on the cables to which it is connected. The weakened signal appearing on the cable is regenerated and put back on the cable by a repeater. If for a real life example, I can tell you that when suppose you are going to the coaching center. This is from your place, and from morning to evening you are working so hard. Working so hard means suppose you have gone to school. After that, after returning from school, you have to go to a coaching center. Then you may feel tired, right? You may feel tired. Then you have to boost up your energy, and you have to drink the energy drink to boost yourself, and again run to the coaching center to prepare yourself for the examination. Just like that, repeater does its job. What is the job actually done by repeater? Actually, repeater boost the signal. The required signal is being boosted by the repeater, because data are carried in the form of signals over the cable. When it travels a specified distance, usually about 100 meters, signals lose their strength. It may be weakened, and when it may be weakened, you cannot get the actual signal, right? Then we have to regenerate it properly, that exactly that particular signal I have to receive. For that reason we use repeater. Clear? Okay. Next we will learn about hub. What is hub? An Ethernet hub is a network device used to connect different devices through wires. Data arriving on any of the lines are sent out on all the others. The limitation of hub is that if data from two devices come at the same time, they will collide. This is the picture of a network hub with 8 ports. Okay. Next, switch. A switch is a networking device that plays a central role in a LAN. Like a hub, a network switch is used to connect multiple computers or communicating devices. When data arrives, the switch extracts the destination address from the data packet and looks it up in a table to see where to send the packet. Thus, it sends signals to only selected devices instead of sending to all. It can forward multiple packets at the same time. So, this is the advantage of switch instead of hub. Okay, a switch does not forward the signals which are noisy or corrupted. It drops such signals and asks the sender to resend it. Okay, so these are all the advantages of a switch. Ethernet switches are common in homes, offices to connect multiple devices, thus creating LANs or to access the internet. Okay, next comes router. This term is also familiar to us. A router. What is a router? A router is a network device that can receive the data, analyze it and transmit it to other networks. A router connects a local area network to the internet. Compared to a hub or a switch, a router has advanced compatibilities. A router connects a local area network to the internet. Compared to a hub or a switch, a router has advanced capabilities as it can analyze the data being carried over a network, decide, alter how it is packaged and send it to another network of different type. For example, data has been divided into packets of a certain size. Suppose these packets are to be carried over a different type of network which cannot handle bigger packets. In such a case, the data is to be repackaged as smaller packets and then sent over the network by a router. A router can be wired or wireless. A wireless router can provide Wi-Fi access to smartphones and other devices. Usually, such routers also contain some ports to provide wired internet connection. These days, home Wi-Fi routers perform the dual task of a router and a modem or a switch. These routers connect to incoming broadband lines from ISP internet service provider and convert them to digital data for computing devices to process. Okay. Next, we will learn about gateway. As the term gateway suggests, it is a key access point that acts as a gate between an organization's network and the outside world of the internet. Okay. So, gateway serves as the entry and exit point of a network, as all data coming in or going out of a network must first pass through the gateway in order to use routing paths. Besides routing data packets, gateways always also maintain information about the host network's internal connection paths and the identified paths of other remote networks. If a node from one network wants to communicate with a node of a foreign network, it will pass the data packet to the gateway, which then routes it to the destination using the best possible route. Look here in this picture. Here is a gateway. Here is server, two server. Here is a server. This is another server. And when this is a server, you can see that PC1, 2, 3, PC1, PC2, PC3, PC4 and PC5. This is a network, and a different network for this IP address. We can see here also PC1, PC2, PC3 and PC4 and PC5, different network. Now this is the gateway and we will choose our network gateways here. When the server is sending something, it will pass through it and it will check the route, the proper destination node here. Okay. For simple internet connectivity at homes, the gateway is usually the internet service provider that provides access to the entire internet. Generally, a router is configured to work as a gateway device in net computer networks, but a gateway can be implemented completely in software, hardware, or a combination of both. Because a network gateway is placed at the edge of a network, the firewall is usually integrated with it. Okay, so these are the very basic terms we have learned here. Now we will learn about network topologies. What do you mean by topology? We have already discussed about LAN, MAN, WAN, all these things. Now, the arrangement of computers and other peripherals in a network is called its topology. The system, actual system. Common network topologies are Mesh Topology, Ring Topology, Bus Topology, Star Topology, and Tree Topology. Now we will learn one by one. Mesh Topology. In this networking topology, each communicating device is connected with every other device in the network as shown in figure 10.5. Such a network, see, this is an example of mesh topology. You can see the figure here, figure 10.15. Look at the picture. There are 6 devices, right? And each and every device is connected through a strong connection. That is, if there are 6 devices, each and every there are connection from 1 to 5 connections will be steady connection will be there. 1, 2, 3, 4, and 5 for each. Okay. So now we will learn the advantages and disadvantages of mesh topology. Such a network can handle large amounts of traffic since multiple nodes can transmit data simultaneously. Also, such networks are more reliable in the sense that even if a node gets down, it does not cause any break in the transmission of data between other nodes because there is a particular exclusive connection, right? For each and every device there is a steady connection. That's why if a node gets down, it does not cause any break in the transmission of data between other nodes. The work is not hampered here. The network is not hampered here. Okay. So this topology is also more secure as compared to other topologies because each cable between 2 nodes carries different data. So this is for security purpose. This is much more secure. However, wiring is complex and cabling must is high in creating such networks, and there are many redundant or unutilized connections. This is the disadvantage of mesh topology. What is the disadvantage? Disadvantage is that when we connect each and every device, then wiring is complex, right? Wiring is complex. If the number of, when you increase the number of devices, wiring connection will be increased also, and so wiring is complex too, and cabling cost is high. Okay, and creating such networks, and there are many redundant or unutilized connections also. Unutilized connections also in that particular network. That's why we have to think that if how many devices are there, all these things depend on these things. How many devices are there, what kind of data I have to transmit, because if there is a much more secure thing I have to transmit, then this is useful for mesh topology. Otherwise, wiring cost is higher, cabling cost is higher. So all these things we have to first think and then decide which topology to be taken for which kind of networking system. So this is our mesh topology, point-to-point connection for each device. Clear? This is the gist of this topology. Now, next one is ring topology. Ring topology, in the name implies each node is connected in 2 other devices, one each on either side, as shown in figure 10.16. You can see it just look like a ring. The nodes connected with each other thus forms a ring. The link in a ring topology is unidirectional. The link is unidirectional. This is very vital point. This is unidirectional. Thus, data can be transmitted in one direction only, clockwise or counterclockwise. Okay, only in one direction. So, if I if I look out for this, that what are the advantage and disadvantage, you can see here advantage, number of cables are very less number of cables you have to use, right? Because each and every device is connected in a circular way, just like a ring. And the disadvantage is here, if one connection is getting down, the total network will be hampered here, because when you are transmitting some data, it will be in one direction only, and when the one connection is getting down, the total topology, the total network will be down. So this is the disadvantage, and the advantage is that cabling cost is low here, less cabling cost, you can see here. Okay, so this is our ring topology. After that, we will learn about bus topology. In bus topology, in figure 10.17, first we will see the picture of bus topology. Look at the picture. This is the bus, and either side of this bus you can see the device here. Okay, so this is our bus topology. You can see different types of devices are here, and each communicating device connects to a transmission medium known as bus. Each communicating device connects to a transmission medium known as bus. Data sent from a node are passed onto the bus and hence are transmitted to the length of the bus in both directions. That means data can be received by any of the nodes connected to the bus. Data can be received by any of the nodes connected to the bus. In this topology, a single backbone wire called bus is shared among the nodes, which makes it cheaper and easier to maintain. Both ring and bus topologies are considered to be less secure and less reliable. I just tell you that this is the disadvantage of ring topology, also less secure. So both bus and ring topology are less secure and less reliable. So this is the disadvantage, you can say. Okay, after that, star topology. What is star topology? In star topology, each communicating device is connected to a central node and looks like a star. Look at the picture here, a star topology. This is the central node is here, and this is connected with the 4 devices. Maybe there are more devices, it will connect with another where will be there, a connection will be there. So which is a networking device and the central node? This central node is known as hub or a switch, as shown in figure 10.18. Okay, so star topology is considered very effective, efficient and fast, as each device is directly connected with the central device. Although disturbance in one device will not affect the rest of the network, any failure in a central networking device may lead to the failure of complete network. So the advantage of this type of topology is that this is much more effective and efficient and very fast, because each and every device is directly connected with the central device. This is the advantage, as well as this is also the disadvantage. When just when the hub, if any failure in a central networking device, that is if hub may lead to the failure, then it will lead to complete failure of that particular network, because this is the central point of this particular topology. Clear? So the central node can be either a broadcasting device, means data will be transmitted to all the nodes in the network, or a unicast device, means the node can identify the destination and forward data to that node only. Clear? So this is star topology. After that, we will learn tree or hybrid topology. The name implies that it is a hierarchical topology in which there are multiple branches and each branch can have one or more basic topologies like star, ring or bus. Such topologies are usually realized in WANs where multiple LANs are connected. Those LANs may be in the form of a ring, a bus or a star. In figure 10.19, a hybrid topology is shown connecting 4 star topologies in a bus. In this type of network, data transmitted from source first reaches the centralized device and from There, the data passes through every branch, where each branch can have links for more nodes. Look, there are 4 star topology, right? And they are connected through a bus topology. So this is a hybrid topology. And what is the advantage of hybrid topology? Advantage is that you can use more than one type of topology in a single topology. That is the real reason it is known as hybrid topology. This is a mixture of all the topologies as you required. Clear? So this is all the types of topology you have learned here. Now, identifying nodes in a network communication. How to identify nodes in a network communication? Each node in a network should be uniquely identified so that a network device can identify the sender and receiver and decide a routing path to transmit data. Clear? We have to know it now. The exact uniquely we have to identify the particular device, otherwise it will be clumsy. Let us explore further and know how each node is distinguished in a network. The first point is MAC address. This is very, very important. MAC stands for Media Access Control. The MAC address, also known as the physical or hardware address, is a unique value associated with a network adapter called NIC. The MAC address is engraved on NIC at the time of manufacturing, and thus it is a permanent address and cannot be changed under any circumstances. Okay, the machine on which the NIC is attached can be physically identified on the network using its MAC address. Each MAC address is a 12-digit hexadecimal numbers, 48 bits in length, of which the first 6 digits, 24 bits, contains manufacturer's ID called organizational unique identifier, and the later 6 digits, 24 bits, represent the serial number assigned to the card by the manufacturer. A sample MAC address looks like this. FCF8, you can see it. OUI means organizational unique identifier, hexadecimal number, and then you will followed by unique serial number. Okay, so this is all about MAC address, very basic definition with example. And here comes IP address. Next, IP address, also known as Internet Protocol address. It is also a unique address that can be used to uniquely identify each node in a network. The IP addresses are assigned to each node in a network that uses the Internet Protocol for communication. Thus, if we know a computer's IP address, we can communicate with the computer from anywhere in the world. However, unlike MAC address, IP address can change if a node is removed from one network and connected to another network. The initial IP address, called version 4, IPv4 in short, that is of 32-bit numeric address written as 4 numbers separated by periods, where each number is the decimal base 10 representation for an 8-bit binary number, and each can look like. A sample of IPv4 address looks like the following one. This is an IP address of a computer, format IPv4. With more and more devices getting connected to the internet, it was realized that the 32-bit IP address will not be sufficient, as it offers just under 4.3 billion unique addresses. Thus, a 128 bits IP address called IP version 6, IPv6 in short, was proposed. An IPv6 address is represented by 8 groups of hexadecimal base 16 numbers separated by colons, and it looks like this. Okay, so this is all about IP address. You people please go through, this is very, very important part. Here comes internet, web, and the Internet of Things. The internet is the global network of computing devices, including desktop, laptop, server, tablet, mobile phones, other handheld, all these things, gateways, you will know. Moreover, smart electronic appliances like TV, AC, refrigerator, fan, light, etc. can also communicate through a network. The list of such smart devices is always increasing. Example, drones, vehicles, door lock, scrutiny, security camera, all these things. We have already studied IoT and WOT in class 11. So the internet is evolving every day, and it is difficult to visualize and describe each and every aspect of the architecture of the internet. Computers are either connected to a modem through a cable or wirelessly. That modem, be it wired or wireless, all these things. And local internet service provider is also there who then connects to a national network. All these things happen. Please go through the entire thing. And here comes the World Wide Web, www. You people know all about this. There is nothing to explain me. So I am highlighting this section, HTML, hypertext markup language. It is a language which is used to design standardized web pages so that the web contents can be read and understood from any computer. Basic structure of every web page is designed using HTML. Then URI, Uniform Resource Identifier. It is a unique address, and after that it is also known as Uniform Resource Locator, URL. Okay, same thing. Every page on the web has a unique URL. You people know this, HTTPS. Then the website address will be here. This is the URL of a page. Domain name is here, and this is the complete URL. After that, HTTP, the Hypertext Transfer Protocol, is a set of rules which is used to retrieve linked web pages across the web. The more secure and advanced version of HTTPS. Many people confuse the web with the internet. The internet, as we know, is the huge global network of interconnected computers which may or may not have any file or web page to share with the world. The web, on the other hand, is the interlinking of collection of web pages on these computers which are accessible over the internet. www today gives users access to a vast collection of information created and shared by people across the world. It is today the most popular information retrieval system. After that, domain name system. What is domain name system? The internet is a vast ocean where information is available in the form of millions of websites. Each website is stored on a server which connected to the internet, which means each server has an IP address. Every device connected to the internet has an IP address. To access a website, we need to enter the IP address on our web browser. But it is very difficult to remember the IP addresses of different websites as they are in terms of numbers of strings. It is easier to remember names, and therefore each computer server hosting a website or web source is given a name against its IP address. These names are called the domain names or host names corresponding to unique IP addresses assigned to each server. For easy understanding, it can be considered as the phone book, where instead of remembering each person's phone number, we assign names to the number and all those things. Okay, so you people please go through domain name, examples of domain name and their mapped IP addresses followed in this chart. You people please go through. And DNS server. What is DNS server? Instead of remembering IP addresses, we assign a domain name to each IP. But to access a web resource, a web browser needs to find out the IP address corresponding to the domain name entered. Conversion of the domain name of each web server to its corresponding IP address is called domain name resolution. It is done through a server called DNS server. Thus, when we enter a URL, this is very practical example, when we enter a URL on a web browser, the HTTP protocol approaches a computer server called DNS server to obtain the IP address corresponding to that domain name. After getting the IP address, the HTTP protocol retrieves the information and loads it in our browser. Clear? Here is a picture explaining the fact which is written in the previous paragraph. Now, a DNS server maintains a database of domain names and their corresponding IP addresses. To understand how the domain name resolution works, we have to understand how and where the DNS servers are kept. Okay, the DNS servers are placed in hierarchical order. At the top level, there are 13 servers called root servers. Then below the root servers, there are other DNS servers at different levels. A DNS server may contain the IP address corresponding to a domain, or it will contain the IP address of other DNS servers where this domain entry can be searched. Okay, so this is the entire chapter about computer networks. This is very basic part we have learned today. This is very important. You people please go through. And I think it will be helpful for you for further classes, and you people please go through. If there any kind of problem, please feel free to ask me. I will definitely clarify your doubt. So till then, next day we will learn the next chapter. So till then, take care and thank you for watching.